This is video number 4 in my series on desktop applications. This is a video editing and processing application. Once again, we have an Enterprise Java Beans JavaFX client, but for this application we use Play Framework servers. The client and the servers communicate via secure HTTP, HTTPS. The servers and the clients are wired up with a Mongo NoSQL database. I'm about to demonstrate a video processing application. This application is called ClearCapture and it processes police body cam videos. Now there are a lot of requirements that influence the application design. One of the requirements was the security around chain of custody. So when the police charge the criminal, everything's going to go to court. Body cam video is evidence, so it's in this chain of custody regime. The police would surrender their body cam when someone was going to be charged, and a third party would then upload the video to a shared FTP server, which would sync with this other server, which we can call the media server. And it's a standalone REST client that pulls the video from the media server to be processed by the ClearCapture video display processing application. We need to run these parts to be able to demonstrate the application. It talks to the media server and the share server via this REST client. The media server and the share server are backed up by a Mongo NoSQL database. At different times, the edited videos need to be exported and shared with the defense team of the people being charged. So it's a very complex application. We'll start by bootstrapping the media server and briefly looking at its source code to get a feel for the technology involved. So it's a Play Framework application. It's capable of transcoding videos. It works with MongoDB. So we have a typical Mongo DAO where we're working with Mongo collections and Mongo data types. That's a typical controller layer. So it presents a REST API to work with the shared server. We have, just to remind ourselves, we have this shared server. This is primarily for sharing the edited videos with other people that need access to those videos. So it syncs with that shared server. So it stays in sync. It knows what's on, it keeps a record of what's on the shared server. So it works with Mongo, works with video transcoding, and it's a REST endpoint for understanding all the data that's in the system and how it's flowing through the system. So we'll just quickly boot the server. So we build it with SBT, that's how we build it. And when we run it, we pass through the information about where the key store is, and we run it from one single runtime jar. So it's booting up now. And you can see we have this Mongo syncing, reaching out to the shared server and understanding what the shared server thinks it has to keep everything in sync. So the media server needs to know what's on the shared server and what's going out to the other actors that use the processed videos. So here you can see HTTPS on 9443. Now that the media server is up and running, and the database via the media server will make video files available to our desktop video processing display, we'll just demonstrate this video processing display. This is the code base. Now it's an Enterprise Java JavaFX desktop, similar to the other ones that I've demonstrated. What stands out is it uses the Video LAN library, VLC, for its video engine. So we need to initialize the video engine, and we initialize or bootstrap our Enterprise Java CDI via JBoss's World. We'll run this. It's booting up now. Boots up fairly quickly. So I'll just bring it onto the screen. So here it is. This is what it looks like. Just extend it so you can see how it resizes. It's got various tabs. So we have a media tab. This shows what videos we have in the system. The devices tab shows what devices we have, what users are in the system. So we'll just go back to the media and demonstrate some of the video processing attributes. Select a video that we want to process. So now we've selected this second video, and this tab here now becomes active, so we can see the details of the video. We can edit the metadata. This section here, if you like, is metadata for the video. So I say this incident was cleared, but we've decided there's more new evidence, so we're going to reopen this. So it's reopened. So as we edit this metadata, you can see this table here is updating. So we can say incident response update. So we can add an update here. This will be reflected in this table here. So the crime was other, but we'll change the crime to a felony because we believe something serious has happened. And we will assign it to a different officer. So that was assigned to John Doe. We'll now assign this video to Jane Doe. So now let's have a look at the video. So this is just a demonstration video. This video is just when the salespeople were trying to sell it to the police department, trying to sell the contract. And this software was a big part of the process of getting the contract. Now that we've made our updates to the metadata, we save our changes to the metadata. And you can see the bottom panel has lost focus. And if we go to the media server, we can see the updates that were made to the database. And now the share server will be in sync because it shares the same collections as the media server. Now what's happening is there's a syncing process between the share server and the media server. So this can be used, it's part of the chain of custody, so if people accuse the police of, like fraudulently editing the videos to include stuff that wasn't there. So everything needs to be double checked everywhere. There's triple lock processes on the chain of custody for the security of the videos. Just look at that again. So we've got our video again and we'll play the video. So we'll bring the video in there. So we'll stop the video. And now we look at the bookmarks. Here we have bookmarks. So the video could be a long video. It could be just some small part of the video that's important. And so we want to be able to target and identify the important parts of the video. That's what we call bookmarks. So this is part of the video processing or editing, if you like. So when I select this icon here, a window is going to pop up. I'll just bring it into the screen. So this is the bookmarking screen. So now when I select new bookmark, it's going to start. So select new bookmark. So now the video is running. Select a time. I can put some notes for that, and now I'm going to save this as the bookmark. So we save, and I select OK. So I want to overwrite that one. Stock. So I've just created a bookmark. So I can do a similar thing for segments. I can identify a segment. So now you can see I have a slightly different icon here. So here's the start. So I'll stop that. I can create an endpoint for my segment. These segments are meant to be small parts. So we can now save the segment. We can write some details. So now we've updated segments and bookmarks. We need to actually save this before it's going to turn up in the metadata display. So we save. Once the save operation has completed, the lower panel once again grays out. We won't see our updates that we just saved to reselect the video in the grid. And now you can see we have segments and bookmarks and all our saved metadata. So this is how the application works. There are some other tabs. We've got devices, so we have a record of all the cameras that are in the system. And we have a record of the users that are in the system. So when people log in to the system, they have various roles. They can perform various editing, various share operations depending on their roles. So for instance, all the police that want to edit have to be camera managers, and an admin has all the privileges, where camera managers have a subset of the privileges. Once you end up with hundreds of videos in the system, you need to be able to filter this grid. So this gives you a way to filter. So you can filter on officers. So that officer doesn't exist, doesn't have any videos yet. This officer has 2 videos. So one is a misdemeanor, one is a felony. So we can filter just to look at the misdemeanors. We just want to look at the felonies. We want to look at something else. We only have misdemeanors and felons. So if we reset the filters, we get back to the original screen. This is the application. It's a complex application. There are a lot of constraints on the design. The look and feel of the application is really important. Tools need to look good. At the time, this was a fairly good looking application. I am a little bit critical of the colour choice. If you worked in the public service, you understand the computers are not that great. So on an old monitor, it could be a little bit hard to discern. So bookmarks, incident date, I think they should have had a slightly different colour so those headings stood out a bit more. When we developed this, there was a professional designer who created wireframes, and we had to develop the actual look of the application based on wireframes that were given us. So what I'll do now is I'll just talk a little bit about the standout features in the code, of which there's quite a lot, but I'll just look at a couple of the ones that are particularly notable as they relate to video technology or video streaming or video processing. So we'll start with the actual video editing, video data display that we just demonstrated. So it uses Enterprise Java Beans, CDI, via Weld. So here we have this producer annotation. So we're using an Enterprise Java design pattern of a producer. Now this is coming from REST data. This signifies the data will come into these lists from REST. So we had all those grids. So the actual video grid that was at the top, and then the video editing metadata display that was at the bottom. So these grids are all the grids that are at the top. So for each type of entity, so we can have users, we can have subsets of users like officers, we can have devices and subsets of devices with certain attributes like unassigned, for instance, and then we can have videos or media types. And we produce these lists from the REST data API, so we qualify. So this is a qualifier, tells the grid this particular list that we're going to build this grid out of comes from the REST API. Just getting back to the grid, so the media table controller handles the top grid where we selected the video, and the media details control handles the lower grid where we edited the video and added the metadata to the video. Video engine, so if we look at our video player, allows us to actually have a video streaming in the view, and then we can process that video, like find positions in the video and attach metadata to video. So that part of it is not that complicated, and it's using the VLCJ for Java library. And the next part is the REST client. So this is the code for the REST client. It's a dependency of the display application. We send data from the display via this REST client to the media server. So when we create a bookmark, for instance, or when we create a segment, when we're updating the metadata, or when we're retrieving media data from the back end, so getting a video, the URL to the video, or what VLCJ calls it any URL, so it can get it over HTTP, or it can get it from the file system. Wherever the video is, we get the URL that we're going to process. This is a very basic REST client. Uses Apache HTTP components. At the time the application was created, this was a well-used library. Now you probably would use something different like OKHTTP or one of the newer HTTP clients, but because it's a few years old, it's using Apache HTTP components. It's just a bog standard Apache HTTP components REST client using TLS over SSL. So here we have the typical stuff that you use when you're using a self-signed Java certificate. Because we don't go anywhere near a browser in this application, we don't need to worry about the browser warnings for self-signed certificates. So we can just create our own certificate, plug it into the Apache HTTP components, and then we have HTTPS for the REST data calls to the backend media server, share server. So we'll look at that a little bit closer now. So now we're back in the media server. We saw how the video editing of the metadata process, how it REST manager, and it talks to the media server via that vanilla REST client. So this is a Play application, and Play has this routes file, so you can see a lot about what the application is doing from the routes file. REST API for media-related operations, so CRUD operations. So we have a media query controller. Here's our media query controller. It handles create, edit, delete, search. Has a token set up for securing the REST API. Media query controller. It's using the Play security module, so we can authenticate endpoints. We have this REST endpoint. It's in a Play server using the Play security. We don't have any sort of a templating engine here because this is just a purely REST API that works with a REST client that is a dependency of the video editing module. It works with Mongo database, so it's storing everything in the Mongo database. And there's a shared server, and the shared server and this server sync together. So when an update is made via the shared server, then the media server has immediate access to the data. So when you start sharding the MongoDB, so when things get big, then the synchronization process becomes a bit complex. So you need to make sure that the partitions of the data, the shared server, and the data it's reading from a partition somewhere, and this media server could be reading data from a different partition. Everything needs to be 100% in sync. So we're doing that with this process, this Mongo Sync Manager. What happens is you can end up with a Mongo cluster. So when things become more distributed, then the syncing becomes more complex. But it was one of the requirements of this application that everything be synced for obvious reasons. Just go over the application design one more time. So it's a distributed application, if you like. That is, parts of it are running on different boxes in different locations. Media goes through the system. Everything needs to stay in sync. Videos go into the system. The database then updates with records for the media, the user that the media is related to, the device it came from, and edits. We keep a record of the edits that are made as we edit the video metadata, as we demonstrated. So now, when we load up our desktop client, it goes out via REST client API, gets all the videos which we can then filter based on the crime types, the users. We can filter on various attributes. And we have the particular videos in our display. We select the video, edit the metadata, create segments, bookmarks, change attributes as to the name of it, what sort of a crime it was, what actions need to be taken, just various metadata. Save that, goes out via the REST client API, updates in the Mongo database via the media server, which syncs with the shared server so that the edits for the video can go out to different actors in the legal process. So the stack uses Play Framework servers, a vanilla HTTP, Apache HTTP components, JavaFX GUI using Enterprise Java, CDI, and of course MongoDB. It's a video processing application that was made to obtain a contract to sell these body cameras from Korea to police departments in New York.